Okay, let's go ahead and finish up these bottom two on page 2 of lesson 5B in module 3. So we had just found a common denominator. 12, 6 went into 12, 4 went into 12, 2 went into 12. So we need to decide what to multiply by. So 2 gets multiplied by 6. 4 gets multiplied by 3 to turn to 12. 6 gets multiplied by 2 to turn it into 12. And the last one already has a common denominator. So that makes this 6/12 for the first fraction, which we know is 1/2. The second fraction turns into 3/12. The third fraction turns into 2/12. And the last fraction stays itself. So this would be 6, 7, 8, 9, 10, 11, 12 twelfths. 3, 6, 12. Yeah. So what does that equal? Is that simplified? Nope. Anything over itself is 1. So there's our answer. That was a fun little problem. Okay, if you want to try one of the multiplication ones by yourself, now would be a good time to turn off the video and try that one. If you want to just go through it with me, that's fine too. So yellow, we look above, is 1/2 plus 2 times red. Red above is 1/4 plus a blue. Blue is 1/6. And 3 greens would be 3 times 1/12. So that's what our problem looks like. And remember, these are 1. So put whole numbers over 1. So 1/2 plus 2/4 plus 1/6 plus 3/12. So is the common denominator 12 again, like on the last one? So it's our largest number. Does 6 go into 12? Yes. 4? Yes. 2? Yes. So it's 12 again. So let's decide what everything gets multiplied by. 2 gets multiplied by 6, so does its numerator. 4 to turn into 12 gets multiplied by 3. 6 to turn into 12 gets multiplied by 2. That one's already 12. So let's write our new numerators. 6/12, 6/12, 2/12, and 3/12. So 6 over 12, 6 over 12, 2 over 12, and 3 over 12. So now all we have to do is add. And I put a check mark here because I followed these directions up here. I didn't want to do it with the pattern blocks like the directions said, so we already did 4. So that's why I'm going to use some of that space here. So 6 plus 6 is 12, 13, 14, 15, 16, 17. And then we always keep the denominator the same, right? So now let's think about this. Is it okay to leave a fraction with that answer? Is anything common between 17 and 12? No. Did they tell us to write our answers as mixed numbers? No. So if it's simplified and they don't ask you to write a mixed number, you can write that. So this is called a simplified fraction. So it is simplified and it's a fraction. So I know in lower grades and high school and stuff, everything had to be a mixed number. When you get to higher level math, we use mixed numbers in word problems lots of times because they make more sense. If you're going to Home Depot to buy lumber, you're not going to order 17/12 feet of lumber. You're going to order 1 5/12. But if you're just doing math problems like we are now, in all your algebra classes, they're going to leave the answers like that. But let's practice writing the the other one too. So we learned in Module 2 to change that into a mixed number. We take the denominator that goes outside. We divide it into 17. It goes once. Then we subtract 5. So 1 and 5 over 12. Remainder over divisor. So because the directions don't specify, either one of these would be okay. Usually though on a test we specify, so just read the directions and you'll know whether to write it as a mixed number or a simplified fraction. And the mixed number has to be simplified too, obviously, which this one is. Nothing goes into 5 and 12. But at this point in time, either one's good. But if I was taking a test and I'm looking at the clock trying to be fast, I'm going to leave it that way because that took extra time. So just read the directions, see what they want. Okay, let's go over to the next page. It now wants us to write an algorithm for addition. So how can we describe what we had to do? So to add fractions, we need what? We make all fractions with the same denominator. To add fractions, Norris, that's an S. We make, or let's say, rewrite all the fractions with a common denominator. So we're just pretending that we're writing to someone that doesn't know how to add fractions. So we're writing out the algorithm, which is the rule. So common denominator. So first we rewrite all fractions so they have a common denominator. Then think about what we did. Then we added the numerators and kept the denominator the same. Then we add the numerators and keep the denominators the same. And what should we write as our last step? Simplify. So that's always your last step of every fraction problem, whether it's add, subtract, multiply, or divide. But in addition and subtraction, we do have to have a common denominator. Then we add the numerators and keep the denominator the same. Simplify. Okay, so let's go ahead and look at the next page. We're getting down there, guys. I think we only have 3 pages left? Yay. Okay, we're going to do the same thing on this one that we did on the last one, but now notice we're going to be subtracting. So let's look at our old page and copy those numbers from it. So yellow was 1/2, red 1/4, blue 1/6, green 1/12. So 1/2. Ooh, that's not really red anymore. Now it's orange. 1/4. The rhombus is 1/6 and 1/12. So I just took those numbers from our earlier page. 1/2, 1/4, 1/6, 1/12. Okay, so now we're going to do the same thing we did on the last one, but we're going to be subtracting. So yellow minus red, 1/2. And this says single color. We're just doing it with fractions. Okay. So 1/2 minus the red 1/4. So look at the larger number and say, does 2 go into 4? And if the answer is yes, that means 4 is your common denominator. So the 2 needs to be multiplied by 2. That means its numerator needs to be multiplied by 2. This one already has the common denominator, so that's going to be 2 fourths minus 1/4, which is simply 1/4. So subtraction is just like addition, except for the second to the last step. Instead of adding the numerators and keeping the denominator the same, we subtract the numerators and keep the denominator the same. And then, of course, we have to simplify. Okay, next we have yellow minus blue, which would be 1/2 minus blue is 1/6. Same process. What's the common denominator? Start with the big one. Does 2 go into 6? Yes. So no need to multiply. Save yourself the simplifying. So again, we have to make this have the common denominator. So 2 goes into 6 3 times. So multiply numerator and denominator by 3. So 3/6 minus 1/6 is 2/6. Can that be simplified? Yes, it can. Both even. Remember, both even. That's your biggest hint ever. When they're both even, we write 1/3. Divide them both by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Okay, red minus blue. So red is, trying to keep everything in the picture. So red is 1/4 minus blue is 1/6. So use the trick I taught you. Does 4 go into 6? No. So then do 6 times 2, 12. Does 4 go into 12? Yes. So there's my common denominator. So this time both fractions are going to need to be multiplied. So 4 goes into 12 3 times. So multiply numerator and denominator by 3. 6 goes into 12 2 times. So multiply them both by 2. So it's looking like 3/12 minus 2/12, which is 1/12. And last one on this page, yellow minus green. So yellow is 1/2 minus green, which is 1/12. And I'm just looking at the numbers above. Common denominator is, look at the big number. Does 2 go into it? Yep. So there's my common denominator. So multiply both of these by 6 to make it 12. So 6/12 minus 1/12 already has it. 5/12. So we need these numbers. So keep a hold of this page because I think we have 2 more on the next side to do. Looks like we might have time to do one of them. So let's look at E on the top of page, I think that's a 3. Maybe it's a 2. Yeah, 2. So double hex, that's our unit, right? So what are we going to put for our unit? What's that equal to? Unit means a whole. So what's one whole? 1. So this is 1 minus, look on your sheet, and it says blue is 1/6 and green is 1/12. And remember how I said every whole number is just over 1. So put this over 1 and treat it just like any other fraction. For some reason, putting that 1 in there just shakes students up, but it's a whole number. Put it over 1 and do your common denominator. 12 is our largest number. Does 6 go into 12? Yes. Does 1 go into 12? Yes. So now I'm just rewriting 3 fractions with 12. So see how I didn't do one different thing on that problem. But for some reason, that 1 just really freaks students out. But just put it over 1 like every other whole number and work the problem.